Okay, well, thanks. Looks like we've got a pretty good list of attendees here today. I'm seeing 24 on there. And again, my name is Gary Gillis. I'm an energy analyst here for the GDS Associates out of the Wisconsin office, Madison office. And I'm going to partner up here today with Dina, who's also an analyst here at GDS out of the Madison office. Both of us from time to time get out to ag facilities, dairy farms, grain operations, different types of swine and poultry operations to do energy analysis and consult for different producers. And the goal today is just share some of our experience, and hopefully everyone here can take something home with them and possibly learn a thing or two also. Just to kind of summarize what we've got planned for during the presentation here today, a short overview. We'll start out by looking at just to summarize kind of what impacts lighting efficiency and following some of the best practices here on farms have for producers, as far as what the energy savings might have, some of the other impacts by having better lighting, different things like that. Take a look at some of the existing technologies that we commonly see while we're doing our energy audits. Some of the traditional versus some of the newer technology, more specifically LED. It seems to be that the market's definitely gone to LED and starting to take foothold in the agricultural market. Also, we'll touch base on some of the different lighting strategies that we find dairy producers, swine producers, poultry producers use and kind of what they're looking for, some of the best practices regarding different light levels for different operations and different areas of the farm, kind of some of the things we run into. And then follow up here with kind of the overview of some of the best practices, if you will. Some of our general best practices we try to make recommendations for and work with producers on implementing. And then we'll follow up here with sort of an example of a couple of different projects just to show the impacts, energy saving impacts, just so everyone kind of can see what's involved with that. So the impacts to dairy producers from an energy saving standpoint, we don't find lighting to be a huge portion of their annual electric bill. For example, on dairy farms, a lot of times lighting might consume 15, maybe up to 30%, but generally 10, 15, somewhere down on that low end of that spectrum. So it's not a huge energy user, but it is the low-hanging fruit, if you will, some of the easiest energy savings to achieve. With that said, when we talk about energy savings on the lighting end of things, we can see with the new technologies now, with LED primarily, we can see up to, I've seen upwards of 50%, even in some instances up to 75, 80% possibly, depending on what they have. Now that's just electric savings on the lighting retrofits, not on the entire facility. For greenhouses, we don't necessarily see a huge opportunity unless they have some artificial grow light technology that they're using. I haven't really seen a lot of opportunity there. And the overall profitability for the producer themselves actually does have to do with the quality of lighting. Not so much in energy savings. Yes, energy savings does have a definite impact on that. But as we'll talk about in further slides here, some of the different light levels and foot candles and how do they manage that can really have an impact on the overall profitability of the farm. To get started here, just sort of have to go through some of I feel like I should introduce, hopefully there's some attendees here that are familiar with lighting technologies, maybe not. So I'll just kind of run through some of the common terminology that we've seen, in working with lighting vendors, lighting layout engineers, working with the farmers and contractors. The term efficacy is is a real important term, in that efficacy of a lamp or a fixture tells us sort of how efficient that lamp or fixture is from a lumens per watt standpoint. So the lower lumens per watt would be less energy efficient. The higher lumens per watt would be more energy efficient. Lumens is that's the amount of radiance from a light source. It's basically, if you want to think about it in real simplistic terms, it's just the light output of a particular lamp or fixture. Foot candles is the amount of light at a source. A lot of times what I think about is, how bright is it? How much light is actually getting down to the surface or in the workspace, and we measure that in foot candles. Lumen maintenance is a term used to describe how well a lamp or fixture will maintain its lumen output over time. So, for example, some of the older technology, high intensity discharge technology might lose upwards of 60%, or 30, 40, 50% of their light output over the life of that lamp. So that comes into play when we start looking at, trying to design a building and put in a fixture that's going to last for a long time. LED, light emitting diode, I think probably most of us can see that. Color temperature is that's used to describe the kind of light that comes out of that lamp. So the temperature, if you will, it's in degrees Kelvin. Lower Kelvin temperature lamps will be more of a yellowish hue, whereas higher temperature lamps will be more of a white or bluish hue. It kind of goes from yellow to white. 5,000 Kelvin would be to describe a sort of a daylight situation. So that's supposed to be pretty close to what it is outside on a clear sunny day. Color rendering index, that's essentially a measure of how well the light source can reveal the actual color. We do run into some situations where it's quite evident in some of our high pressure sodium technology, which is a yellow hue, and that it's very hard to distinguish what the true color is. And some of that'd be a low CRI. On a high CRI index, that's where we can get more refined, actually see the kind of color that's whatever we're trying to see. So some of the technologies we see in doing our energy audits here, still running into quite a few incandescents, and incandescents definitely, I think, have their place in some of those situations, maybe closets or bathrooms or, in different areas of the farm where we just don't see a lot of use. Incandescents are a cheap lamp. They are the lowest efficacy as far as efficiency goes, 7 to 20 lumens per watt, which on an A-lamp technology, which A-lamp is a screw-in type of lamp, is definitely on the low end there, and the shortest life. But, in some areas of a farm, it might be totally applicable. One nice thing about incandescent over compact fluorescence is that the incandescent light bulb doesn't have a sort of a slow start during cold weather. So in those situations like machine sheds or different areas of the farm where the lights might only be used a couple times a year, and they might only get used in the winter months when it's dark out most of the time, maybe the farmer needs to go and start their tractor or what have you. Just a flip of a switch for a few minutes, it's on. You don't need to wait for it to warm up. It just makes sense. Compact fluorescents, they are about 75% more energy efficient than your incandescent counterparts. We've seen a lot of these on dairy farms. Most of the time, producers will use CFL light bulbs in areas where they're on more often than not, where they can turn them on and they warm up and there's not an issue. They're more efficient. They 45 to 55 lumens per watt. They definitely have a longer life. Anywhere from 10 to upwards of 12,000 hours rated life is what you can expect out of a compact fluorescent. Only downside here is they do have mercury, and definitely short to start sometimes. LEDs, we are definitely seeing more and more of this technology being, embraced by the agricultural community. definitely more energy efficient, up to 80% more energy efficient than the old incandescent light bulbs. Anywhere's efficacy rating anywhere from 80 to 100 lumens per watt. So you can see there's quite a difference there. Also, long hour life, so upwards of 100,000 hours we've seen. Typically on these packages you'll see them rated for about 50,000 hours, which is still really, really good. And the price definitely has come down on those, which I think is the primary reason why we've seen more and more of that technology being implemented. Linear lamp technologies, now this is a little slightly different. On farms, especially when we're dealing with colder environments in the winter, like we have up here in the upper Midwest, we're going to see a lot of T12 HO fixtures. T12 is an older technology. In fact, it's been phased out, started to been phased out in 2010 as of the Energy Act of 2005. We've got high outputs generally are better cold starting, which is why the farmers and contractors have pushed T12 high output technology. Only problem is it's pretty low efficacy rating and real short life. So from a standpoint of replacement, now with the Energy Act of 2005 implementations, it's getting harder and harder to find these replacement lamps and ballasts. So the farmers are sort of forced to have to go to a new updated technology, either T8 or now TLED. T8 technology, higher efficacy rating than your T12, anywhere from 60 to 110. Definitely a longer life. We're looking anywhere from 20 to 36,000 hours rated life. We see a lot of this in replacement technology for T12s. It's a fairly inexpensive or easy replacement. A lot of these fixtures can be quickly retrofitted by replacing the ballast and lamp of these T12s to make it a fairly economical way to do a pretty simple retrofit to get some energy savings. And then now we are seeing a lot of TLED technology coming into the marketplace I would say just over the past year or two, where the manufacturers have refined the process and gotten the price point down where it's economically feasible. TLEDs are basically like a T8 or T5 lamp, 4-foot lamp. They have a high efficacy rating, anywhere from 80 to 110 lumens per watt, real long life. Some of these will use external ballasts, or will use existing T8 ballast rather. Some of these different manufacturers will have TLEDs that will use line voltage. Essentially, they'll just completely get rid of the ballast, and they'll tie their 120 volts right to the end pins, and there's an internal driver built in to the TLED technology. And then there's also TLEDs that will operate off from an external driver. So they'll have basically a 12-volt supply. They'll replace an existing ballast, swap out the lamps, and operate it that way. HID technology, or high-intensity discharge, we see a lot of these on farms in various different applications. Primarily, though, we're going to find these on your exterior type of applications, or what we call high bay applications, like the picture here. We can see this is a grain drying station, HID fixtures. Those are big. I believe they're 1,000-watt HIDs. And then on the lower right are some high bay technologies, 400-watt HIDs. These are metal halides inside of a holding area on a dairy farm. So we see some metal halides. We've got efficacy ratings of anywhere from 45 to 80 lumens per watt. Rated life is anywhere from 10 to 30,000 hours. The HID technology is real distinguishable because we can just look at the color of the light when they're operating. So if it's more of a white light, we know it's going to probably be a metal halide. In comparison, a high-pressure sodium is more of a yellow light. If you've ever seen those, you'll know exactly what I'm talking about. Efficacy rating of anywhere from 65 to 75 97 lumens per watt, and they do have a slightly different rated life, roughly around 24,000 hours. But again, these would be primarily our high bay technology and any exterior, whether it be yard lights, area lights, corral holding area lights, things like that. One technology that I personally haven't seen much, I've only seen a few of them. I've worked with a couple different vendors that have pushed this out on the market, but I've not seen it in practice too often. Induction. It's basically a type of, except it's used more bay application that might be used to replace HID. From what I've seen, it's different in that there's no electrode in this lamp. It has a very good efficacy rating, 70 to 80 lumens per watt, and a very high rated hours, operational hours. But I think the price on these, if I understand right, is pretty high, which is why we haven't really seen a lot of this technology being implemented on different farms. And then I just wanted to touch base with the fact that we're seeing more and more LED technology. A lot of farms are questioning us and, interested. I don't know if they go to trade shows or where they're getting this information, but when we're doing our energy audits, they're always asking about LED. And historically, the LED technology, even up to 3-4 years ago, was real questionable, as far as being able to throw out enough light and provide the lumens that are required for different areas. But we've gotten to the point now where it's really starting to take hold, and we've seen a whole different group of applications being available on the market with LED technology, from high bays, LED high bays and wall packs. We do have linear fixtures, which are different than your TLEDs. Linear fixtures are sort of a self-contained unit. It's just either an 8-foot or 4-foot fixture that's already self-contained and built in. You can just swap out the entire fixture. Troffers. On farms, we don't find your troffers. Troffers are more your fixtures that are used in an office setting. Once in a while, we'll find them, 2 or 3 or 4 lamp, like T12 or T8 fluorescence generally is what they were. They're more your office type of setting. LED troffers, they are already built in. It's just a matter of swapping out the entire troffer. And then now we're seeing the introduction of actually qualifying mogul-based lamps, which would be like your HID replacements. Basically, you bypass the ballast of the HID fixture, and you can put in they call them a corn cob light. That's what they call them. But we're seeing more and more of that technology being introduced on the market. Now, I just wanted to kind of go over some of the recommendations we might we commonly make when we do our energy analysis on farms. Sort of this chart here, table rather, is just sort of a summary of what we found during our investigation and kind of what some of the recommendations might be. Some of the common incandescent to CFL or LED, we sort of distinguish that based on, do a cost-benefit analysis based on what the hours of operation are. If it's an incandescent bulb that's only on a few times a year, I'm not sure it really makes sense to spend the extra money to go LED. So in that case, we might suggest to go to CFL. T12, if we've got any T12 technology on the farm, we'll take a look at options for either T5, T8, TLED, or LED fixtures. So we might talk with the producer to find out, hey, what's your goal here? Figure out what makes sense. Work with contractors to kind of see what the price points are and make decisions based on that. Any T5, T8 lamps, generally a pretty easy swap out with TLED. If we can use the TLED that have the electronic ballasted option built in, it's just a matter of swapping those lamps out with your TLEDs and save about half the energy. HID technology, we'll take a look at what's available for going to a fluorescent-based fixture or LED fixture. So that's kind of an idea of what we find when we go on farms and what we're looking for. So from here on out, I think I want to turn it over to Dina. Dina, I hope your voice has gotten a little bit better today.
Yeah, I think it's doing all right. If you guys can hear me, I'll do a quick sound check.
You're good.
Okay. So just really quick, we're going to go through some, just a touch base on some dairy, swine, and poultry recommended light levels and just optimization controls, such like that. We did kind of go through the different size types of T5, T8 fluorescent tubes versus T5, T8 like LED tubes, or TLEDs. So just moving forward with the dairy recommended light levels. You know, as mentioned earlier, a foot candle or a lux is the light level at the working surface. So lumens in the light output, lumen is the light output from a lamp. So when you're looking at lights, you really kind of want to look for the average lumens, not the initial lumens, to get some good quality lights out there. With use of a light meter, you can measure the number of foot candles within that subject. So this will kind of help to determine what you have and your goal, what you need or what you might want in your first specific task. The dairy recommendation slide will kind of show you some freestyle recommended intensity of light levels, foot candle 15 to 20 in a milk room, upwards of 20. And again, kind of individualized. You're going to have your own perception of what you want, but these are recommended light levels. We'll move on to just a few notes about the swine operations. There's been quite a few studies out there. So when considering a change of light in a swine facility, maybe look into dimming systems that could help stimulate the sunrise and sunset to reduce stress caused by sudden or frequent changes in the light that might disrupt their natural habitat. Studies have shown that a red light is said to be perceived as a bit of darkness to a pig, yet it's still a good source of service light as you're going through the facility so as not to disturb their sleep cycle. Lighting is pretty important in these facilities, not just swine, but other facilities, any animal housing, just for quality of health and how it affects behavior of the animal itself. So I'll move on just to talk a little bit about the swine recommended light levels, again, based on the type of housing, the light level, recommended light level, and the photo period, which is how long the light is actually going to be on. Research indicates pigs are not colorblind, but they're not colorblind, but they don't have the same clarity as the human eye. So there's a lot of variables to consider when installing lighting in a swine operation to produce a uniform light in those different situations, those different housings, those different age levels. In a nursery area, just to pull one out, they're suggesting 5 as the light level for the foot candle or the lux on about 8 hours a day. Some light in rooms 24 hours a day, depending again on the growth of that animal. Move on into poultry operations. Much like the swine housing, poultry as well needs to have a nice uniform light, and again, specific to the bird type, or the poultry type, and the growth level. I would suggest, again, research has shown, consider dimming capabilities, especially for service areas and such, and again, just for quality of health and behavior effects on the different type of poultry. So there was a study out a while back, and I know my own personal with raising a bit of poultry. The younger tended to like the light. The older tended to not need as much light, but they did try to avoid the shaded or darker areas. So a nice even distribution to avoid that, I believe would be beneficial to their health. Again, we're going to have a little slide here that's readily available online. You can research it, just recommended poultry light levels for chickens, turkeys, breeder toms, and the different age level, the minimum light levels, and again, the time of day that the light should be on for them and off for their rest period. Stepping into just a little bit of lighting optimization, and this is pretty important when you're looking for energy efficiencies. You know, the chart or the slide just kind of goes through a few good ideas of trying to control the light. Occupancy sensors, maybe an area commuting traffic. We tend to turn lights on and not shut them off. Office lights are left on. Hallway lights are left on. So again, occupancy sensors for those areas where lights may be left on and are past their use, then those automatically turn off. That's going to have a great saving. Timers and photocells for animal needs for, again, that sunrise, sunset, or even extended daylighting to maybe get a few pounds of milk more in the free stalls, and again, maintenance of the fixtures to help keep them up to their performance levels and life expectancy. A lot of folks don't realize just keeping things clean can increase the longevity and keep that efficiency level up to where you need it. They have less frequent change-outs of light. We'll move on to just, obviously in any situation you want to follow the code compliance. So electrical contractors have knowledge and training in this, but choosing the right light or fixture for the application, whether it needs to be gasketed or sealed, finding the highest lumen per watt, having a brighter light with a low power consumption, again, making sure that they're cleaned, maintained. If you got to spray them down, again, having them sealed and gasketed, then it's easier to keep them a little bit cleaner. Just a little bit more in lighting optimization, always double check to ensure your light choice is either Energy Star or Design Lights Consortium DLC certified. There's a qualified product list, again, online that has these all listed. Seek out utility type programs, state and federal programs that might help to offset that upgrade with some incentives or grants. They also have good advice on what to use. Having a lighting layout that gives you spacing, proper proposed foot candles for your facility so you get that real nice uniform light and don't have the shadows or the dark spots. So you're able to install less light with proper spacing. And just we'll move into just a couple of examples of some LED retrofits. Gary put together kind of a nice little calculation here where a dairy farm with a kWh rate of 0.11 cents per kilowatt hours was considering replacing 20 T12 high output 8-foot fixtures, fluorescent fixtures in a parlor pit with 8-foot LED fixtures. So they calculated the simple payback on that, where you can see the wattage currently used, the 150 watts saved. It brings it down to a simple payback of about 2.8 years. So if you're in the farming business or agricultural business, wherever you're looking at changing out lights, if you look at that, you know that you're in that for a good amount of time. So a 2.8-year payback or less than 3-year payback on this is actually a really good opportunity for you. We'll go into another example, just utilizing timers or photocells. Kind of an instance where I was talking in the earlier slide where human traffic, hallways, offices, people are not shutting off lights when they could be shutting them off. So this farm currently has 10, say 200-watt LED high bay fixtures and a holding pen with lights manually turned on and off. It's suspected that the lights are left on when they're not needed to be probably about 30 hours per month. So again, if you do the simple calculation of math, you're coming back with a less than 2-year payback on savings, just making sure that those lights are not running past their use. If they're not needed, we want to make sure that those are off. So just in conclusion, just going through the number of slides we have here, there's a lot of options out there for energy efficient technologies. Again, research is the key and what works best for you. The market is primarily moving to the LED, and the good thing about that is there are a lot of options out there, a variable amount of different sizes and types for all kinds of applications and situations. The different types of agriculture facilities have different requirements, which we discussed in a few of the slides, for behavior, for health, just maybe milk production. But again, we want to make sure that you're having the right design layout of lighting so you're getting the proper lighting that you need for the safety and other practices. Kind of finalizing it up, bringing it by being aware of the lighting best practices, producers can make informed decisions. And again, that's most important. The gift of knowledge is never going to hurt you. So anything going forward that you can, consult on or get information on, again, is just going to be a bonus to you, not only for energy efficiencies and a real good payback and the longevity of light, but again, for your facility, animal behavior, and health. I think that kind of wraps it up. I'll bring it over to Gary and Julia and see where we got any questions.
We don't have any yet, but if anybody has any questions, go ahead and type them in the chat window, and we'll answer them as they come in. But again, as I said before, this presentation has been recorded, so as soon as it is available, I will be emailing it out to everyone for future use. We do have a question here. It says, please discuss the occupancy sensors in the last example, ceiling mount, wall mount at $100 install cost.
Okay, so the example I come up with there was just sort of a simple wall-mounted occupancy sensor that's fairly inexpensive to install. Some of your higher-end methods for controlling high bay lights might be individualized fixture-mounted sensors. In that case, we're definitely going to be looking at more costs there. When we start talking about that, a lot of times the benefit is during the actual install lamp. So I just kind of wanted to throw that out there, say, hey, we've already got LED fixtures. What happens if we throw in a simple, wall-mounted occupancy sensor, area occupancy sensor, like cheap, fairly inexpensive. But when we start looking at, in this case, the producer obviously upgraded, but there's still, even though they upgraded to an energy-efficient light, there was still an opportunity to better enhance that system by installing an occupancy sensor, and it might have been able to be done in a better way, maybe a little bit more expensive way. And when we initially sourced those fixtures out to go with more of a fixture-mounted occupancy sensor, in that case, it definitely would add some more cost to the project. I hope that answers the question.
I think so. Again, we'll wait just a few more minutes here if anybody else has any last-minute questions. I just want to thank everyone for their time this morning. All right, I'm not seeing any other questions. Again, thank you for sharing some part of your morning with us this morning, and have a wonderful day.